Hello students, welcome to this math video tutorial on Area Supernote Part 2, or Part B, Area of Parallelograms. Let's start with this introduction. A parallelogram can be chopped and reconstructed to form a rectangle. Therefore, the method to finding the area of a parallelogram is the same as the rectangle. Now we just finished solving a number of questions regarding the area of a rectangle, so this shouldn't be very difficult. Remember that the height is always perpendicular. So let's see if you remember how to spell that word. Perpendicular. Now in geometry, we have a symbol to show perpendicular, and it looks like this. It has that little square to signify a right angle. Remember that the height is always perpendicular to the base. So let's see what that means. So this is what we're talking about here. We have a right angle. The base is here, but I've extended that base so that I can form a right angle to show the height. The height has to be 90 degrees to the base. And that's how you know. You got to look for this little clue here to show you where the height is. Okay? Now that doesn't mean that the base goes from this point all the way to here. The base only goes from here to here, but I've only extended it so that I can get the right angle. I could have drawn the perpendicular inside the parallelogram as well. Okay, so let's start with our 5-line solution. All right, here we go. First line is the formula line. Area of a parallelogram equals base times height. This formula should seem very familiar to you. In fact, it is the exact same formula as area of a rectangle. And that's why we made that connection between a parallelogram and a rectangle. They are essentially the same shape in terms of area. All right, line number 2. Do you remember what it is? It's the information line. Okay? So the base is 0.3 meters. Now, we could have made this the base, I guess, because the base and the height have to meet at 90-degree angles. There is no stipulation that the longest side is the base. That's only for the rectangle. All right, so let's make the height 0.1 meters. All right, line 3 is the substitution line. Well, we don't know what the area is. We know that the base is 0.3. We know that the height is 0.1 meters. So please get out your calculators and please solve for this area. Zero 0.3 times 0.1 is 0.03. And don't forget our units. Our linear measurement was meters. And because this is area, don't forget the squared. Therefore, the area is 0.03 meters squared. Okay. Let's go on to example 2. Now example 2, I've thrown in something that you're going to see. So it leads to you proving that you understand the relationship between the height and the base. There are 3 measurements given in this parallelogram. However, one of these measurements is not needed. So in a parallelogram, we always look for the dotted line because the dotted line shows the height. So we probably need this measurement here, 4 centimeters, okay, because it's connected to the dotted line. Well, How is that dotted line? Which line is the dotted line a 90-degree angle to? In other words, what is its perpendicular? Well, this line up here, this side, 5 centimeters, is actually not connected to the height at all. So that is probably the line that is not necessary, or the measurement that is not necessary. Whereas this measurement, 17 centimeters, is the length of this line, which is a 90-degree angle to the height. So this is probably the line that we're looking for. Okay. So let's start with our 5-line solution. And again, if you're getting the hang of this, then get ahead of me. First line is our formula line. Area of parallelogram equals base times height. Line 2 is our substitution line. Well, we've just determined that our base is 17 centimeters. Our height is 4 centimeters. Now in this case, the height has to be 4 centimeters because that measurement was inside the parallelogram. If it's inside the parallelogram, it can't really be the base, can it? Next is the substitution line. So we don't know the area, and then we know the base is 17. We know the height is 4. So using your calculators, (17 times 4), 68 centimeters squared. Final line is the conclusion statement. Therefore, the area is 68 centimeters squared. Okay. All right, example 3. Example 3 is very similar to example 3 in our first video on area of rectangles. Okay, so let's see what we're given here. So we'll start with line number 1, our formula line. Area of a parallelogram equals base times height. So let's see what we know. Well, we're given the area in this case. Okay, so let's write down what we know. The area is 6,000 meters squared. What else do we know? We know the base. The base is 30 meters. And we're asked to solve for the height. Third line is the substitution line. Well, if we look at our formula, the thing on the left-hand side is the area. Well, we know the area. The area is 6,000 meters squared. I'm just going to leave the units out for now. Equals, do we know the base? Yes, we do. Do we know the height? No, we don't. Okay. Now remember, our goal is, on the right-hand side, we look for the height. We want to have the height standing alone on the right-hand side of the equation. So what's in the way of h being alone? Well, what's in the way is times by 30. So how do we get rid of times by 30? Well, we do the opposite operation. So if we want to get rid of times by 30, we have to divide by 30. And whatever we do on the right-hand side, we have to do on the left-hand side. Okay? So this is the step where we're using algebra and solving equations. All right, so times 30 divided by 30 simply cancels each other out. Okay? The only thing left on the right-hand side is the h. Now let's look at the left-hand side. 6,000 divided by 30. Well, please use your calculators to solve for that. So 6,000 divided by 30, hopefully you got 200. Okay, so let's not forget our concluding statement. Therefore, the height, remember it's not the area, that's not what we were asked to solve. The height is 200, and let's not forget, sorry, our units of measurement, it is meters. Now be careful, it's not meters squared because it's not asking for the area. It was asking us to solve the height. So hopefully these type of questions are getting a little bit easier to understand. Okay, so this concludes video 2 on the area supernote, section B, area of parallelograms. Thanks for watching. Bye.